right, it says solve the system. Okay, so remember, whenever I'm solving a system, I'm looking for both the x and the y value. My goal is always to set up a situation where I have an equation that just has one variable in it. So in this case, I notice that this y and this y are the same. Obviously, those are the same y and they're the same letter. This y is equal to this, and this y is equal to this. So if this y is equal to both of these things, then these two things must equal each other. So I'm going to write 2x plus 11 equals negative 3x minus 14. I'm going to draw a line down the middle. And now I'm going to get all my x's to one side, right? And there's x's on both sides. Can't have that. I'm going to choose to get rid of this negative 3x. I could have also subtracted 2x from both sides, but for me, I like to put the x's on the left, and I also like to make my x's positive. So this actually meets both of those requirements. So love that. Here we go. And now I need to get x by itself. I'm going to take away 11, deal with addition and subtraction first. Negative 14 and negative 11, I have 14 negatives, 11 more negatives. That's a total of 25 negatives. And then to get x by itself, I'm going to divide by 5. I get x equals negative 5. Again, I'm not quite done. I still need to take this negative 5 and plug it back into these equations to find y. So I'm going to plug in right here. And look, I'm actually going to plug into both equations. So this is basically going to be me checking my answer. Because if I get the same thing on both equations, then that means for sure that's correct. 2 times negative 5 is negative 10 plus 11. Negative 10 plus 11, that's the same as 11 minus 10. That's 1, right? And remember, this is y equals 1. Okay, same over here. Negative 3 times negative 5, that's a negative times a negative is a positive. Okay, 15 minus 14 is 1. So I got 1 both times, and I can feel really confident that that's the correct answer. Okay, here. Notice it says, is 4, negative 5 a solution to the system of equations? Notice I don't have to solve. I don't have to. Why? Because it already gave me the answer, right? The question is this the correct answer? This is my x, this is my y. Let's see if it works. What I'm going to do is I'm just going to take each of these equations, and I'm going to plug in, oops, that's a 17. I'm going to plug in these values and see, does it work? Is that the solution? So I'm plugging in negative 5 for y, equals 3 times x minus 17, and my x is 4. Let's do the math, right? There's no math to do over here on the left. I'm just bringing it down. 3 times 4 is 12, minus 17. And 12 minus 17 is indeed negative 5. So this is a solution to this first equation. Let's see if it's a solution to the second equation. Second equation is 2x minus 3y equals 10. So my x is 4 again. My y is negative 5. And let's see, 2 times 4 is 8. And then this is negative 3 times negative 5. That's positive 15. 8 plus 15 is 23. Well, this is not true. So is this a solution to the system of equations? No. It is a solution to the first equation, but not to the second, which means it's not a solution to the system. Okay? In order for it to be a yes, it would have to be yes and yes. Okay, solve the system. Ooh, here's a doozy because it looks kind of like this one. And I'm going to use elimination, but the difference is here, remember I had a 4 and a negative 4, and it just, bam, canceled. Love that. Ugh, here I do not have that situation. There's not two numbers here that are going to cancel. So what I do is I have to multiply to create that situation where I have a positive and a negative of the same number. Okay, now, I have two choices. I can focus on the x or focus on the y. It doesn't matter which you choose, but whichever you choose, you got to just kind of stick with it. So here, if I chose the x's, I would say, okay, 3 times 5 is 15. And I would say, okay, I want one of these to be positive 15 and one of them to be negative 15. Okay, so let's take a look. Okay, now why did I choose 15? The reason I multiplied them together is I just need a number that I can multiply both of these numbers to. And the easiest way to do that is just multiply them together, and then we know that that number is a multiple of each of these. Okay, so this is negative 3 right now. This is 5. My goal is 15. My goal is to have one positive 15 and one negative 15 so that it'll cancel. Since this one's already negative, I'm going to go ahead and multiply it by positive 5 to keep it negative 15. So 5 times negative 3 will be negative 15. And then 5, I want this to be positive 15, so I'm going to multiply it by 3. Okay, so I'm going to do this multiplication, and I'm going to write it right here. And I'm going to do this multiplication and write it right down below. So 5 times negative 3, that's negative 15x. 5 times 2, that's 10y. 5 times negative 12, that's negative 60. Okay, then right here, 3 times 5, 15x. 3 times 3, that's 9y. 3 times 20, that's 60. Okay, and just be really careful with signs all the way through. That tends to be where most mistakes happen. Okay, this cancels. This is 10y plus 9y, that's 19y. And over here, I have negative 60 plus 60. What's that? That's 0. And then, look, I can like divide by 19 here, right? Doesn't really matter. But y is definitely going to be 0, right? 19 times what is 0? 0. So y is 0. So look. Okay, now careful here. That's a y value. Don't lose track of your variable. Sometimes students won't write the variable here, and then when they get here, they're like, oh, x is 0. Nope, x is not 0. Y is 0. Okay, now let's plug in y is 0 to one of our equations to find our x value. And then we'll just quickly check in the other equation. So let's plug in here, negative 3x plus 2y equals negative 12. Y is 0. Okay, so this just becomes negative 3x equals negative 12, right? Because 2 times 0 is just 0. I'm going to divide, and I get x equals 4. Okay, and then let's check it. Let's check in the other equation. So this is 5 times x plus 3 times y equals 20. 5 times 4 is 20 plus 0 equals 20. That is true. 20 plus 0 is 20, and we are good. All right. Here, this is the g function. Okay, so what does a g function do? It takes an x, multiplies it by 5, and then subtracts 6. This is the f function. What does it do? It multiplies x by negative 3, and it adds 4. So what this says is, hey, use the g function and plug in 2. So I'm going to grab the g function, which is 5x minus 6, and instead of x, I'm going to plug in 2. 5 times 2 is 10, minus 6 is 4. This says, go get the f function and plug negative 5 in. So I'm going to negative 3x plus 4. Let's plug in negative 5. Negative times negative is positive, and I get 19. Okay, here. Oh, there should be. Okay, here, this is, we deal with the inside first. Okay, so I'm going to plug, first I'm going to plug negative 2 into the f equation. All right, so I'm going to get the f equation, which is negative 3x plus 4. I'm going to plug in negative 2. So that's 6 plus 4, that's 10. I'm not done yet, because then that means this is 10. That's what I'm plugging into g. So now I'm going to take that 10, plug it into the g equation, and the g equation is 5 times x minus 6, and we're plugging in 10. So that's 50 minus 6, which is 44. All right, next one, graph the system. Okay, these are two equations. These are both in slope-intercept form. I know it doesn't look like it, but they are. They both have a slope and a y-intercept. They're just a little bit hard to see. Okay, but these are the ones that tend to trip us up. Notice here, there's no x. Where's the x? It's being multiplied by 0, right? So look, this is y equals 0x plus 4, right? That's why the x isn't there, because whatever the number is, if we multiply it by 0, it's just 0. So this is y equals 4. Now here, we actually do have an x. So this is y equals 2x, and what's missing is the y-intercept, and that is 0. Okay, so now let's graph. We start at the y-intercept. So in this case, I start at 4. Now, this is a slope of 0. Now, you could just memorize that a slope of 0 always looks like a horizontal line. Okay, or you could think, oh, my slope is a whole number. It's 0 over 1. So I'm going to rise 0, which means I'm not going to go up or down, and I'm going to run 1. And here's my line. Okay, this is the line y equals 4. Okay, this is line y equals 4. And then this line here, and let me actually, right over here, you'll see why. This line is 2x plus 0. So I'm going to start at my y-intercept, which is 0. Okay, and then my slope is 2 over 1. Up 2, right 1, up 2, right 1. Okay, now notice these are really easy to mix up. So what I would really recommend is on the final, actually write it out for yourself, right? Oh, there's no x, that's 0x plus 4. And oh, there is an x, so that's 2x plus 0. That way, and then you still are using your same method as always, which is starting at the y-intercept and then the slope. So that way, I think you're less likely to mix them up if you just take a moment to write them out kind of the long way, right? And the solution is right here. So that's 2, 4. Okay. All right, find the slope of the line that goes between negative 4, 2 and 1, negative 5. Remember that the slope formula will be given to you on the test. It's in the little reference section at the top of the test. This is y2 minus y1 over x2 minus x1. That's the slope formula. And what we have to do first is label the points. So this right here, this is x1. Oops, sorry, this is, let me draw a little box here so we can see it, right? This point is point number 1, x and y. So this is x1 and y1. And this point over here is the second point, and that's x2 and y2. So let's do our math. y2 minus y1 over x2 minus x1. Let's do the math. Negative 5 minus 2, that's 5 negatives, 2 more negatives, that's negative 7. This double negative right here becomes plus. So this becomes 1 plus 4, which is 5. Let's look and see if we can reduce this at all. Is 7 and 5, are they divisible by the same thing? No, they actually happen both to be prime numbers, and they don't divide to be a whole number, right? So nothing really to reduce. This is a negative divided by a positive, so even better is to write it like this. But this is also okay. This would be correct, but even better is like that. All right, just a couple more. Let's solve and graph this inequality. I'm going to treat this inequality like an equal sign. Okay, the only thing I'm going to have to remember is I want the x on the left, which it already is, so problem solved there. And if I divide by a negative, which I will, I'm going to have to flip this sign. Let's first start by getting rid of addition and subtraction. This becomes negative 3x is greater than negative 13 plus 7 is negative 6. Here I'm going to divide by a negative 3. Okay, notice right here. See how I'm dividing by a negative? It doesn't matter that this number is negative. It doesn't matter like what the result is when I divide. It matters I am dividing by a negative, and so we need to flip the sign. Okay, so this is x. This is negative divided by negative is positive. This sign, it was open to the left before. Now it's going to be open to the right. Okay, in terms of graphing. So here's my answer. Okay, we ask ourselves 2 questions to graph. Is the circle open or closed? Okay, and it's open if we don't have a line underneath, and it's closed if we do have a line underneath. So in this case, I don't have a line underneath, and my circle is an open circle. So that's the first question you ask yourself, and then the other question you ask yourself is left or right. And if we're talking about a less than sign or a less than or equal to, we go to the left, and if we talk about a greater than or equal to sign, we go to the right. But the big thing to remember rather than memorizing the signs is saying, okay, look here, the smaller opening is towards the x, right? The mouth wants the 2, so the x must be the smaller number here. So we're going to shade the numbers that are smaller than 2. This is a less than sign, and we're going to shade the numbers that are less than 2. Okay, last question. How many solutions do each of these graphs show? Each image has 2 lines. Write the number of solutions in the line below the graph. Here are the choices. No solutions, 1 solution, infinite solutions. Remember, what this is actually asking is how many times do the lines intersect? Do the lines meet? Okay, here, they meet right here. They meet once. This has 1 solution. Here, they go on forever and they never meet, right? They'll never meet. It's like train tracks, okay? These never meet. There's no solution. There's no point at which the lines will meet. And here, these lines meet at every point. They meet here and here and here and here. This is a line, and it's another line sitting on top of it. And they meet here, and they meet here, and they meet here, and they meet here. It's like when you say goodbye to someone and you walk in the same direction. It's awkward. They meet forever. This is infinite solutions. All right, there it is.